Welcome to General Physics 1. So in this video, we're going to discuss friction forces. And in the later parts of our lesson, we're going to solve problems involving friction force. So the objectives in this video, in this lesson, is for you to draw a free body diagram involving friction forces and to apply Newton's laws of motion to obtain quantitative and qualitative conclusions about the forces acting on a body. So in our past discussion, in our previous examples, we assumed that the surfaces of the body in contact are frictionless, because if we suppose that the surfaces are frictionless, it makes the solution to the problem is here. But we know that in reality, friction forces acts on a body and will oppose some of the forces that are acting on that body. So to define a friction force is a force that opposes the direction of the applied force and the direction of the motion. So kung walang applied force, and if the body is sliding on a ramp, for example, then the friction force will oppose not the applied force but the force that is causing that body to move. And sabi nga natin that friction force is a force that is always opposite to the direction of the motion of a body. So if we have here a rolling ball, yan, a ball rolling to the ground, and if this ball is rolling towards this direction, ang bagal pala ng bola. Okay, so if this ball is rolling towards this direction, so there will be a force that is opposing this ball. So if this ball is rolling towards this direction, we know that the direction of the friction force must be towards this direction. So straight yan, class. Okay. So ano yung ginagawa ni friction force? So why do we have friction force? So friction force arises due to the unevenness of the surfaces in contact. So for example, ayan. So for example, we have here two skaters. So, yung isa, ice skater, yung isa, roller skater. So, ayan. So, yung isa nag-skate siya doon sa cement, sa asfalto. At yung isa is skating on a smooth surface. So, which between the two will experience greater friction? So, we know that the one who will experience greater friction is this skater who is skating on a cement. Because the surface of a cement, or for example an asphalted road, is when it comes to unevenness, it is more uneven compared to this ice rink. So smooth yung ice rink, so although it has some degree of unevenness or irregularities to it, compared to the cement ground will have more irregularities when it comes to the roughness of its surface. So therefore, we need to consider the different factors that are affecting the friction. So the first factor that affects friction is the nature of the surface. So suppose we have here a book that is sitting on a table. Kung titignan lang natin yung table at yung book, hindi naman natin makikita kung ano yung itsura ng surface nila. But if we look on the surfaces of these two objects, if we look it at a microscopic level, we'll see that there are uneven irregularities in the surfaces of these objects. So ayan. So these irregularities causes these objects to interlock with each other. So if we have here this object, and then the other object would have this, for example, this is the table. Ayan. So these irregularities of this surface causes the friction forces. So if this object moves to any direction, towards this or towards this direction, so of course these irregularities will exert some opposing force towards the direction of the motion of this body. So that is the reason and the one of the factors that affects our friction force. So we need to consider the nature of the surface. So ang iba-ibang object, iba-ibang surface is composed of different materials. So depending on the materials that composes a surface or an object, iba-iba din yung value ng friction force that will be experienced by a body. So this opposing force coming from the irregularities is given by or measured by the coefficient of friction. So we have two coefficient of friction. We have the static and we have the kinetic coefficients of friction. So later we'll discuss what are the kinetic and static frictions. So this coefficient of friction is the ratio. This is the ratio of the forces coming from the irregular surfaces of bodies in contact. So when one of this body moves, of course, for example, itong libro, tinulak natin papunta dito sa direction na to. So meron tayong may exert na force. So this as an opposition to that motion, this table will exert an opposing force towards this. So the ratio of those opposing force is given by this. The ratio of the force experienced by these two is measured by this coefficient of friction, and it depends on the nature of the surface, on the material. So here are some of the common coefficients of frictions of some common material. So we have here rubber on concrete, we have here rubber on asphalt, steel on steel, steel on steel, that greasy, leather on rock, ice on ice, steel on ice, rubber on ice, and the rest. So we have here coefficient for static friction, and we have here a coefficient for kinetic friction. So later we'll know what is the difference between the static friction and the kinetic friction. So the second factor that is affecting the friction is the amount of force pressing the surfaces together. So suppose we have here two blocks. One weighs, for example, yung color green, for example, yung green weighs 50 Newton, and the other one weighs the yellow one weighs 100 Newton. So if we applied a force, the same amount of force towards these two blocks, we know that one of the blocks will move faster and will cover greater distance. So, yung block na yon na magta-travel na mas malayo at mas mabilis yung galaw will, of course, be our color block green, which has lesser weight compared to this one. So, therefore, yung friction force natin is proportional sa weight as well as to the normal force, but we use the normal force instead of the force due to gravity, because the normal force is the force that comes from the surface of the supporting object. So yung force due to gravity is a force coming from the gravitational pull of the earth. But yung normal force natin is a force coming from the surface of a supporting object. So the friction force is directly proportional to the normal force. So therefore, we need to consider the ratio of the opposing forces coming from the unevenness of the surfaces in contact and the amount of force that interlocks the uneven surfaces of the body. So before we move on to the equation to solve for the friction forces, let us first discuss the two main types of friction force. So we have, number one, we have the static friction. So when we say static friction, it is the force opposing force acting on a stationary object. So if we have here an object, for example, it is 200 kilograms, and we applied a force to this object. So for example, nag-apply ka dito ng 50 Newton force. So it is obvious that this 50 Newton force is not enough to move this 200 kilogram object. But the question is there a friction force that will counteract this applied force? So this is our applied force. So the answer there is meron tayong friction force that will oppose this applied force. So although hindi gumalaw yung ating object, meron pa rin tayong static friction, and that is the reason why we won't be able to move this object kapag mas mahina lang yung force na linagay natin. So therefore, in order to move an object, we need to overcome the static friction. So the static friction, yan. So yung static friction, if this is the direction of our force applied, the static friction will be directed towards this direction. So kapag if we attempt to move this object by applying a force, there will be an opposing force that will prevent us to move this object. So this will be our force of friction, and this friction is a static friction since hindi naman gumalaw yung object when we applied a force to it. However, if the object starts moving, for example, meron tayong box dito which is for example 10 kilograms, tapos nag-apply tayo ng mga ilan kaya, for example, nag-apply tayo ng 200 newton na force. So 200 newton is big enough to move this object. So once the object starts moving, so the friction that will act on this object is not anymore a static friction. So the friction that will oppose this object is the kinetic friction. So kaya nga kinetic, so meaning moving. So friction, kinetic friction is an opposing force, a force opposing object in motion. So that is the difference between the two. So kapag nag-apply tayo ng force and then yung object where we applied the force did not move, did not change its motion, or did not move, or just remained stationary, then the static force, the friction that is opposing our applied force and the motion is static friction. But if we applied a force to an object and that object starts moving, the friction force that is acting or opposing the motion and our applied force is the kinetic friction. So class, static friction, so a static friction is greater than kinetic friction. So the maximum amount of friction that is the maximum amount of friction that will oppose the motion of a body or will oppose the applied force is given by the static friction. Therefore, we need to overcome static friction in order for us to move our body, to change the motion of a body from rest to moving. So if we are going to graph this, if we have here, ayan, so the force applied towards this direction, and we have here the friction force. So our static friction is, this is our maximum static friction, and we have here the kinetic friction. So meaning we need to overcome this maximum point of static friction in order for us to move an object. So kapag na-overcome natin tong highest value of static friction given by the surfaces of the force of the surfaces of the bodies in contact, then we can the body will now start moving and will experience kinetic friction. So the kinetic friction is less than the static friction. So to solve for the static friction, so again, first we need to create a free body diagram to analyze the situation. So what are the forces acting on the body? So suppose this is on a flat surface. So for a flat surface, ito yung mangyayari. So we have here the force due to gravity, we have here the normal force, we have here the force applied. For example, this is the direction, and we have here the force of friction. So if this situation is for stationary, so for example, this force did not start this object moving. So stationary. So analyze natin yung forces. So the net force that is acting on this body. So yung natin, so along the y-axis, along the y-axis and the x-axis, since sabi natin stationary, the net force must be equal to 0. So along the x-axis, we have here the force applied plus the force of static friction. And then for the y-axis, we have here the force due to gravity plus the normal force. But we know, class, here, since they are oppositely directed, we know that the value of the opposing force, instead of adding, we're going to subtract. So therefore, this will be the net force acting along this horizontal is Fa minus the applied force minus the static friction. So static friction because the object did not start moving. So it just remained stationary. Along the y-axis, since pareho lang naman, balance naman yung ating force. So ayan, so the net force acting on y-axis is force due to gravity plus the normal force. So we suppose that the normal force is positive and the downward force is negative. So therefore, negative force due to gravity plus the normal force, pwede rin natin siyang i-write as normal force minus Fg. Ayan. So to look for the static friction, sabi natin, 'di ba, that we need to consider the nature of the surfaces and the normal force. So therefore, to solve for the friction, for the static friction, we multiply the coefficient of static friction with the normal force. Kasi sabi natin, directly proportional naman siya dito sa dalawa. So, our friction is directly proportional to the normal force as well as to its coefficient of friction. So, here, in this case, this is static. So, therefore, coefficient of static. So, yung coefficient of friction is denoted by mu. So, yan. So, now, to solve for the force, so in this case, para sa horizontal force natin, the net force along the horizontal, so is equal to force applied, ayan, minus, kasi sabi natin opposing force, minus the force static, the force of friction. So here it is static force, so instead of F of S, we can write here mu of S times the normal force. Ayan. So for the kinetic friction naman, so if the force, so yan, moving body. So if the force applied causes our body to move, therefore we already overcome the maximum static friction. So therefore, the friction that will act on this body will now be the kinetic friction. So, to look for the kinetic friction, to analyze this type of problem, so again, ayan. So, net force, alam natin that the net force is not equal to 0. Kasi alam natin that this is already moving. So, for the y direction naman, the net force is equal to 0 because the normal force and the force due to gravity will cancel each other. So, for the horizontal net force, we're going to add summation of the forces acting along the horizontal, force applied plus the kinetic friction. So since kinetic friction is oppositely directed compared to our force applied, therefore instead of addition, we use here subtraction. And for the y direction, ganyan din. So, force due to gravity plus Fn. So, since they are oppositely directed, then one of these two will be negative. So, depende sa kung anong i-assign nyo. But let's assign the upward force to be positive and the downward force to be negative, so that this would be equal to Fn is equal minus Fg. If we equate it to 0, of course, Fn will be equal to Fg. Ayan. And then, so here, so for the kinetic friction naman class, so dito, so the summation of forces along the x-axis, when the object is already moving, the force, the friction force acting on it is the kinetic friction. So to solve for the net force, net force, we just subtract applied force minus the kinetic friction. So to solve for the kinetic friction, we use this equation. So, mu sub k, or the coefficient of kinetic friction, times the normal force. So, this is now how we look for the net force of an object that is acted upon by a friction force. So, let us have some problems. Example problems. So, for problem number 1, a 100 kilogram crate rests on a rough horizontal surface. The coefficient of static friction and coefficient of kinetic friction are 0.5 and 0.1 respectively. What is the normal force? And B, what is the value of the maximum static friction? C, what minimum horizontal force is needed to start the motion of the crate? And letter D, what is the value of kinetic friction? So, step number 1, identify muna natin yung mga given. So, we have here the kinetic friction. We have here the mass of the body is equal to 100 kilogram. And then, we have the coefficient of static friction, mu of S, is equal to 0.5. And then, coefficient of kinetic friction is equal to 0.1. So, as you can see, ang coefficient of static friction, if we have the same surfaces, the coefficient of static friction is greater than the coefficient of kinetic friction. And then, ayan. So, letter A, what is the normal force? So, let us first draw our free body diagram. So, before we answer these problems. So, we have here our mass, 100 kilogram mass. And then, ayan. So, ang gusto nating malaman, what is the normal force? So, 100 kilogram mass will be acted upon by the force due to gravity and will be acted upon by another force, which is the normal force. So, we want to know the value of the normal force. So, since we know that this is not moving along the y-axis, then our summation of forces along y-axis must be equal to 0. So, to look for the summation of forces, we assume the upward force to be positive and the downward force to be negative. So, Fn minus Fg, so this is for letter A. Fn minus Fg is equal to 0. So, ano yung value ngayon ni Fn? So, to look for the value of Fn, we need to look for the value of Fg because we know that normal force is equal to force due to gravity. So, therefore, we also know that force due to gravity is equal to mass times the acceleration due to gravity. So, normal force is equal to, we have here a given mass, 100 kilogram, times the acceleration due to gravity is 9.8 meter per second squared. So, 100 kilograms times 9.8 meter per second squared. So, let me get my calculator. 100 times 9.8 is 980. So, therefore, the normal force is 980 Newton. So that is for question letter A. So let us move to our second problem. So what is the value of the maximum static friction? So sabi natin, the maximum static friction is the yung force ay the static friction that we need to overcome in order to move our object. So para magalaw mo yung isang object, para ma-set mo siya in motion, you need to overcome the maximum static friction. So, let us look for the maximum static friction. So, again, i-drawing ulit natin dito yung ating, ang tawag dito, object. So, yung object natin is 100 kilogram. And we know that the weight of this object is equal, the normal force experienced by this object is equal to 980 Newton. So to look for the static friction, we know the equation is F of S, or static friction, is equal to the coefficient of static friction times the normal force. So we also know the value of our coefficient of static friction, which is 0.5. So substitute natin to dito sa ating equation. So we have 0.5 times 980 newtons. So 0.5 times 980 newtons, kalahati ng 980 is 400. Excuse me. So the maximum static friction is 490 newtons. So anong ibig sabihin nito? So ang ibig sabihin nito, that you need, in order to move our object, the minimum horizontal force. So if you want to move this object towards the horizontal force, because ito yung nandito yung cause ng ating friction, di ba? Dito sa surfaces that are interacting with each other. So in order to move this object, this mass, you need to apply a force that is at least 490 newtons. So therefore, to answer our letter C, the minimum horizontal force needed to start the motion of this crate is 490 newtons. Ayan. So, isulat natin sa ating next page. Ayan. That for letter C, the minimum force needed to move the crate must be equal to the maximum static friction. Therefore, if our Fs, so if our static friction equals 490 newtons, then the minimum force, so palitin ko na lang, then the minimum force must be 490 newtons. So, ito yung answer natin sa letter C. So, ang minimum force natin is equal to our maximum static friction. So, this 490 newtons is enough to move our object, to start our object moving. So, when the object starts moving, so we already overcome the maximum static friction. So, therefore, the friction that will act on this body once it starts moving is the kinetic friction. So, what is now the value of the kinetic friction? Okay, so what is now the value of our kinetic friction? So, letter D. So, the value of our kinetic friction is given by the equation F of K is equal to the coefficient of friction of kinetic friction times the normal force. So we know that the value of mu sub k is equal to 0.1, and the value of the normal force is equal to 980 Newton. So therefore, ang tawag dito, the value of our kinetic friction would be, so multiply the kinetic, the coefficient of kinetic times the normal force, which is 980 Newton. So 980 times 0.1 is 98. Asan na yun? So F of K is equal to 98 Newton. So this is now the kinetic friction that is opposing our body. So if we have here our body, so sa first part natin, when we applied a force to this object, if we applied a force to this object equal to 490 Newton, now the object will start moving. So once the object starts moving, it will experience a kinetic friction equivalent to So mali class, mali. So yung 490 Newton is the maximum force required to overcome the friction force. So once we overcome the friction force, we have here our minimum force. So yung 98 Newton na kinetic friction is our minimum force to maintain the motion of the object. So tanggalin natin to class na nasa taas. Sorry. Ayan. So 98 Newton is also the minimum the force is the amount of force needed to maintain the constant velocity of our object. So the constant velocity of the object. So once you move the object, once you start the object, once the object start moving, the force required now to maintain that movement is lesser than the amount of force needed to start that object moving. So that's why when we push, for example, a cabinet, so kapag ginalaw natin yung cabinet, sa unas mahirap siyang galawin, pero once that cabinet starts moving, it becomes easier to push because the maintaining force to move that object is lesser than the force required to start it moving. So therefore, itong 100 kilogram crate na to, ang required force to move this 100 kilogram crate is 490 newtons. But once this crate starts moving, the force required, the minimum force required to maintain the motion is 98 newton. So equivalent to our kinetic friction. So this is for example number 1. So in our next video, we're going to discuss another example of friction force. So see you in our next video.